system and its type. So it is the basics of our classical mechanics.
First we have to know this coordinate system, then our classical mechanics will be more easy. Okay. So what is coordinate system? Anyone can say what is coordinate? We already studied in mathematics, coordinate geometry we studied. So what is coordinate system? Representation of point. Suppose I am telling where is anagram. So one can say C is two person and beside of that girl, and here from Nanma's back is anagram. So if we are talking a exact point, we can refer some other source. So like that, if I am talking about some point like here P, which has mass L.
This is an object. Suppose I am talking.
So in this object, how we plot this object? Suppose I am talking, you plot this object. So if I am taking this like in 2D, this is our x-axis and this is our y-axis. So in 2D, from this is the origin, and from x-axis this is this much of distance, and from y-axis this is this much of distance. Okay. So this is x, this is y, and its coordinate is x, y. So simply we can plot any point like that. So we have to discuss about coordinate system not only in 2D but also in 3D. So as we are B.Sc students, we are going to discuss in 3D also how we plot a point. So we know we have two types of object. Like one is macro object, macro particles. Another one is micro particles. So in macro particles, suppose I am taking macro object, we can discuss the macro particle in our classical mechanics. But in micro particle, where you use that mechanics is quantum mechanics. Suppose here I am telling a point, this point, we can find the momentum and but the speed, velocity, the momentum and the position we can find in of this macro particle. But for micro particle we already studied, we cannot find the exact position, momentum at a time. So suppose here I am taking t equal to t. So we can find the exact momentum and position of this particle, but we can't find for micro particle. Okay, that's the thing. So for macro particle we are using classical mechanics, and for micro particles we are using quantum. So like in coordinate system, there is two types of coordinate system, as already I discussed in 2D and 3D also. Suppose here I am telling coordinate system. So it's two types, like in 2D and in 3D. So in 2D we can have two types of coordinate system. One is our Cartesian coordinate system. So first is Cartesian coordinate system. I am writing CS for coordinate system. Second one is our polar coordinate system. Polar coordinate system. In 3D, there is three types of coordinate system. These two coordinate system we already studied before. That I am discussing this also. Don't worry. And here in 3D, this is a new thing for us. So first we are going to study about Same Cartesian coordinate system in 3D. Here 2D, here 3D. And the second one is spherical coordinate. Coordinate system. Third one is cylindrical. Cylindrical coordinate system. So these are our 5 types of coordinate system we are going to study in this seminar. So first one is our Cartesian coordinate system. Second one is polar coordinate system. Third one is Cartesian coordinate system in 3D. And fourth is spherical coordinate system. Fifth one is cylindrical coordinate system. So one by one we are going to discuss about the things. Suppose here I am telling first Cartesian coordinate system. I already discussed is in 2D. 2D means two axes is there. This is x axis. This is y axis. Suppose I am taking the object which have mass m. So this object of coordinates how much? Is from x axis. The distance is x distance. And from y axis, the distance is y. So, suppose this length is r. Okay. So, coordinate is x, y. We know how to write the position vector. We already know. Suppose this is our. So here first we have to write the position vector. So position vector is r. What is the position vector here? R. So r represents in x-axis the magnitude is x and the direction is in x-axis I cap. So x I cap plus in y-axis the magnitude is y and the direction is j cap. Here I cap, here j cap. So y j cap. In 2D we got the position vector. Okay. Then we have to write the expression for velocity. So what is the expression for velocity? If we have the position vector, then how can we find the velocity vector? Derivative. Simple. So v vector equal to dr vector with respect to time dt. So if you are we are differentiate this, then what will be the result? Dx by dt I cap and dy by dt j cap. So here I am writing dx by dt I cap and plus dy by dt j cap. But to easy our expression, we are using in coordinate system for dx by dt, we can use it as x dot. Okay, in full our classical mechanics, we are going to use dx by dt as x dot and dy by dt is y dot. Same as if I am writing dx square by dt square, sorry, d square x by dt square. This is the double differentiation. So d square x by dt square, we can write it as x double dot. Okay, for dx square y by dt square. What we can write this? As y double dot. Okay. So here our final expression for velocity vector is dx by dt as x dot I cap plus
y dot j cap.
very good y dot j cap. Okay, understood? Then R is our acceleration. So for the acceleration a vector, what we can write? What is acceleration? If we have position vector and velocity vector. Yeah. So in terms of position vector, we can write as d square r vector by dt square, or we can write what dv by dt. So anyone we can put and get the answer. So what is our final expression for this acceleration? If we can put the r vector here, r vector we got. This is our r vector. If we can put here the final expression for acceleration. What is the final expression? This is x double dot. So x double dot I cap plus y double dot j cap. So we got three expressions. This is one expression for acceleration. This is the position expression, and this is the velocity expression. So for Cartesian coordinate in 2D, we got three type of expression, but we have to calculate the kinetic energy also. So what is the kinetic energy? The general equation for kinetic energy is half mv square m. V square means in dot product we can write v dot v. So here I am writing v dot v for v square. If we put this expression x dot I cap plus y dot j cap in this equation, so what we will get for our kinetic energy? Half m x dot I cap plus y dot j cap. If we do the dot product, what is the final expression? Yeah, for this, if I am dot producing this, what will get? So x dot into x dot and y dot into y dot. Then I cap dot I cap we know 1. So final expression we will get x dot square plus y dot square. So this is our expression for kinetic energy. Okay. In Cartesian coordinate of 2D, we get this 4 expression. This is the expression for position vector, and this is the expression for velocity vector, this is the expression for acceleration, and this is the expression for kinetic energy. All of you understood this?
Yes.
We are going to next our polar coordinate system. So next we have our polar coordinate system in 2D. So what is polar coordinate system? So in polar coordinate system, the expression is like suppose we have an object here. Same. Suppose we have a micro particle here of mass m. So it is a distance from origin is r. Okay. So in polar coordinates here, the Cartesian coordinates we are writing x and y. From x-axis, how much it is moving, and from y-axis, how much its distance, we know from this Cartesian coordinate system. From polar coordinate system, how can you get this position? So this is the distance from origin and how much we bend here. Okay, from x-axis, how much that line came here. So this is the expression for theta. So in terms of r and theta, we have our polar coordinate system. So this is the expression for Cartesian coordinate. We know xy, and for polar coordinate system r and theta. In terms of r and theta, we are going to discuss our polar coordinate system. So as you know, for position vector r, we already know in terms of vector we already studied in class 2. So for r we know r vector magnitude into r cap. Already we know this expression in a vector. So this is our position vector in polar coordinates. Okay. So what will be our velocity? What is the expression for velocity? We have to differentiate this. So if we are going to differentiate that coordinates, so what we will get if we are differentiating that? First, d vector equal to dr vector by dt. If I am writing r vector here, so d by applying chain rule, what we can write here? So first term into derivative of first term into second term. So first derivative of first term is dr by dt into r cap plus r vector means r is there, then d by dt of r cap. So this is our expression for derivating this expression. We will get by applying chain rule, we will get this expression. So we know dr by dt is our what? Velocity. What we can write? We can write it as r dot. So dr by dt is r dot. So here I am writing the final expression like d vector equal to r dot r cap plus r into dr cap by dt. So r is there. We have to write this. So what is the final result for this expression? So this is the expression like we have to write this is theta. So this is a long derivation. There is the derivation is not included in our syllabus. In MS level we can go through this derivation, but the final expression I am writing. So this expression is theta dot theta cap. So this expression I am writing as theta dot theta cap. So theta dot, you know what is theta dot? D theta by dt and this theta cap. So we can write it as r dot r cap plus r into this expression theta dot into theta cap. So this is our final expression for velocity. If you are if you want to know more for that derivation, then I can share you that. But this is not included in our syllabus because it will take 1 hour for derivating that. How it's come d r cap by dt theta dot into theta cap. So if you anyone can want, then ask me. I will share that thing. Okay. So okay, that is our acceleration. Okay. So our acceleration is, you already know acceleration is dv by dt. So v term we got like this. Again we have to differentiate this all the terms. So that derivation is not in our syllabus. Only we have to know the expression. So the final expression I am writing when we will going to derivate this expression by applying chain rule here. We will get the derivative. So first derivative into second, like that we will get. So final expression I am writing. So the expression, final expression is r minus r theta dot square into r cap plus we have another term remaining, r theta double dot plus 2 r dot theta dot into theta cap. So this is the final expression for our acceleration, and this acceleration is known as our radial acceleration, and this acceleration, this term is known as our transverse acceleration. In whole chapter we will going to discuss this radial and transfer. So it is so much important. So the final expression for acceleration is r double dot minus r theta dot square into r cap plus r theta double dot plus 2 r dot theta dot into theta cap. This is our final expression. So if anyone want to derive that, then I will share, because it is very hard to derive all these things. Okay. So next is our kinetic energy. We already know the expression for kinetic energy. What is the expression? Half mv square. So v square we can write as v dot v. So after putting this expression of v vector, we can get dot product as the final expression I am writing. So the final expression for kinetic energy is half m r dot square plus r square theta dot square. So this is our final expression for kinetic energy. Okay, and this is our velocity, this is our acceleration. All clear up to this? So next we are going to discuss about the Cartesian coordinate system in 3D. Next is our Cartesian coordinate in 3D. As you know, Cartesian coordinate in 2D is the coordinates are x and y. In 3D, x, y, z. 3 direction is there. So like this. We always know Fleming left hand rule and all we studied in our electrodynamics, that chapter we already studied these kind of things. So these things are used, we can use in this 3 type of coordinate system. So first is our Cartesian coordinates in 3D. Suppose I am an object here. So in 3D we can have 3 dimensions. So this is our x-axis, this is our y-axis, and this is our z-axis. So in order to find this position, so what we have to do?
we have to find the position of this particle. So in x-axis, the distance is x from y-axis, y from z-axis, z. So the coordinates are x, y, z. You already know the expression for r vector. What is r vector in this system? Yeah, nice. X I cap plus y j cap plus z k cap. In term of velocity, that is v vector. It is v vector is equal to, yeah, because we have to derive this dr by dt. So if we are going to derive, then the expression is x dot I cap plus yes, y dot j cap plus z dot k cap. Okay. Then for acceleration also we have to write what is the expression for acceleration? The double differentiation of position vector. So acceleration equal to x double dot I cap plus y double dot j cap plus z double dot k cap. So this is our three final expression. And last is our kinetic energy. So what is the expression for kinetic energy? As you know, m v square. So v dot v. If we are going to dot product this expression, what will get the final expression? So kinetic energy equal to half m x square plus y square plus z square. Dot is there or not? Yes. Because velocity term has dot, so x dot square, y dot square. Okay.
Yes.
So we got four expressions for our Cartesian coordinate system. Then see here, the Cartesian coordinate system is like this. So this, if we plot a plane here, like this is the distance from x-axis, and this is y, and this is z. So this is our Cartesian coordinate system in 3D. So next we are going to discuss the spherical coordinate system. So what is the expression for spherical coordinate system? In polar coordinates we are using r and theta, and for Cartesian coordinate we are using x, y, and z. Okay. For spherical coordinate, what we are going to discuss for spherical coordinates is r, theta, and phi. So r, theta, and phi. I am going to discuss about that. Suppose this is a sphere. Okay. This is a sphere. So in 3D, suppose this is our x-axis, this is our y-axis, and this is our z-axis. Okay. So first, if we are going to discuss about this, suppose here I am plotting a point of distance r. Okay. So this coordinate is, already we know, in Cartesian coordinate system, x, y, z, x, y, z. But we don't need these coordinates. We have to write in terms of r, theta, and phi. That's the thing. Like this, we have x and y. We have to write in polar coordinates in terms of r and theta. But here we have same expression of Cartesian coordinate, but we have to write in terms of r, theta, and phi. That's the thing. So here, what from Z axis, this angle is called theta. Okay. R we got, theta we got. Then next is phi. So phi is, suppose here I am taking a distance like phi from this, from x axis, the angle is phi. So it is like this. So suppose I am taking this point like this. This is in sphere. You can imagine this things. Suppose this is from theta. Suppose here I am taking a point from here. It will like phi, and here the distance is r, and here the theta. So this plane is moving like this in spherical manner. This is a plane. You got the plane? So this plane is moving like this in spherical manner. So from x-axis it bends like phi, and from z-axis it bends theta. So in circular motion, in Newtonian mechanics we already studied about circular motion. We know in circular motion theta is what? Theta is angular displacement. So theta is angular displacement. We know angular velocity also. So what is the expression for angular velocity? Omega. So omega is d theta by dt. So this is our angular velocity. So here how much angle it's displaced. This is our final point. So how much it displaced from z-axis, that is theta, and how much it is displaced from x-axis, that is phi, and r is the distance from origin to this point. All of you understood? Yes. So now we are going to find the position vector and velocity vector, acceleration and all. So in spherical coordinate, the expression for position vector same as like here, polar coordinates. So we have r vector magnitude into r cap. This is our expression for, okay. So in velocity, what is our coordinates here? The expression. As we are going to derive derivative of this dr vector by dt, we will get the expression for spherical coordinates. So the final expression for that is writing r dot r cap plus r theta dot theta cap. Already we have this expression in our polar coordinates in 2D. So next term is r sin theta phi dot and phi cap. So this is our final expression for velocity. Okay. So next we are going to we have to remember this. Okay. So if the derivation is too long, if I am going to deduct it, it will take 3 days, 5 days, like that. All the expression. So only I am writing the expression. So next is our acceleration. So we already know what is acceleration. dv by dt. So if we are going to derive this term, then we will get the final expression of acceleration. It is a long term. I am sharing these notes to you. Okay. This acceleration, no space is here. It will take. It is almost 1, 2, 3, 4, 5 terms, big terms. Okay. So that term I will share. Then kinetic energy. You got the format how to write this. We can write in that way. So in kinetic energy, half m v dot b. So if we are putting this expression in this term, then we will going to get the expression for kinetic energy. Okay. So next is our cylindrical coordinates. For cylindrical coordinates, same. Suppose here I am going to discuss in terms of R, I and Z. So R, I and Z. Suppose here I am taking a cylinder. So this is our x-axis. This is our z-axis. Sorry, this is our y-axis and this is our x-axis. So this is a cylinder. Okay. So here I am going to discuss about, suppose a point like this. We have a plane like this. This distance is r. Okay. And this angle from x-axis, like same previously, from like spherical coordinate system, from x-axis, this angular displacement is phi. Okay, we will get that expression. So now, if we are going to move, this is the z. We have to write in terms of r, theta, and z. We got r, we got phi, and z also there. So this is the this height is z. Suppose this window, this is the pole and this is the window. Suppose I am rotating it 360 degree. It will form a cylindrical coordinate system. Okay. Suppose I have a give me a pen. Suppose this is a pole. Okay. So if I am rotating this direction, so this is our z-axis. Okay. And this is our y-axis. Suppose if I am pull this angular displacement is phi here. Suppose I am applying force in this direction, it will move like this. So it will form what? A cylinder. So this is the thing. If I am moving like this will form a cylinder. So we have to write the expression for position, velocity, acceleration and kinetic energy. So first position is our I. First I am writing this. So R cap and Z cap. Z cap. So this is the expression for position. So like that we can write in terms of velocity, then we can write in terms of acceleration, then we can write it as kinetic energy. So this is all about our cylindrical coordinate system. I have a problem also, but due to less of time, I will give it as homework. Okay. Lastly, I have a problem based on this polar coordinates. We have to find the velocity of that. So in terms of r and theta, we can find that answer. So I have that question. If you want to write that question, I will post it. Okay.
Then first we go studied for Cartesian polar in 2D, and 3D we are discussing Cartesian spherical and cylindrical. So this is all about our coordinate system. The last time, if it is not exist, suppose this coordinate system is not exist. So what is there? So now imagine what if coordinate system doesn't exist. So pilots, aircraft controllers, passengers in flight, they will not get the proper direction. Suppose the pilot, he studied about the coordinate system, which path that flight will travel and all. In order to getting that things, we have to study physics. In physics, we have to study about coordinate system. Okay, so this is all about my seminar. Thank you so much.